Can and then also I have a grammatical evolution running on my computer. Can you teach me how much they may slow each other down, if any at all, and and how much the GE is using all 14 cores with multi core. And I don't know what the above ML models use. Yeah, I don't know, so I'm not gonna act like I know. A lot of people will act like they know. I know nothing, dude. Only thing I know is I know nothing. I gotta figure it out. Oh, one, lean on me. I'll lean on you. All right, let's read it. I'm sorry to hear about the numerous errors you're encountering. The understanding the errors. I'm not running into errors, right? All right, we're gonna go to a freshie. Luxy, you're up. You are up, Lux. So let's read it. When running multiple machine learning models, especially resource intensive ones, it's important to understand how they utilize system resources and how they may impact each other's performance. Here's some moondev.com has a roadmap and resources if you want that. Here's some insight into how your ML models and grammatical evolution algorithm might interact. Core utilization, multi-core utilization. If your GE algorithm is using all 14 cores on your machine, it is likely consuming a significant portion of your CPU resources. This means that any other processes running on the machine, including your ML looper, might have limited CPU resources available. Model resource usage. The resource usage of your ML models depends on several factors, including the complexity of your model, the size of the data being processed, and how well optimized the code is. If your ML looper also utilizes multiple cores, but does not do so efficiently, it may slow down considerably when contending for CPU resources with the GE algorithm. Potential slowdown, total resource usage. If both systems utilize the CPU heavily, you could potentially see performance degradation in both processes. For example, if your ML looper tries to use 8 cores and G is already using 14, and if they are competing for the same resources, both may experience a slowdown. Type of tasks. If your ML models are not CPU bound and spend a lot of time waiting for I/O operations or other resources, the overall impact may be less pronounced. However, if they are performing heavy computations, you could see noticeable slowdowns when resources are shared. Estimating slowdown. The best way to measure how much one task slows down another is to conduct benchmark tests. Run each task individually and record how long it takes. Then run them together and see how long each takes compared to when they were run individually. Performance monitoring while running your applications, use system performance like Task Manager on Windows to measure your CPU and I/O usage. In summary, the slowdown caused by running multiple resource-intensive applications can vary greatly depending on how those applications use the CPU and other resources.